Hello, AP Calculus students. It's Mr. Ford here in the home studio. It's about 95 degrees today, and it's nice and cool down here in the basement. Anyway, this is the last video in the series on the summer packet, and this is topic V, graphical solutions to equations and inequalities. And what we're going to do here is, this is the DESMOS version of this video. So if you've already watched the video on how to do this with the TI-84 calculator, you already have all the answers, which is fine. And we're going to do those exact same problems. I'm actually have the answers already written down on these. I'm just going to walk through how you can do the same problems in DESMOS. Now, DESMOS is an excellent tool. It is superior to the 84 in a handful of ways. It's inferior to the 84 in a handful of ways. It is really good at getting a good look at the graph immediately, and it's really good at teaching you some key ideas from a graphical perspective. However, it is not allowed on the AP Calculus because, or let me try that sentence again. It's not allowed on the AP Calculus test because, well, you can't fit it in your pocket. And DESMOS is available online for free as a browser, but it's not so much available, or it's on your phone as an app too, but you can't bring either one of those things in the room with you on the test. So unfortunately, right now, it's kind of in this weird standstill. However, we are going to walk through how to solve the problems on this thing with DESMOS, so let's get into it. Again, we've already solved these problems in the other video, so let's start with number 1. This is going to be a quick video too, because I think you'll realize how DESMOS is a much faster tool than a lot of these are. So for number 1, how to do this. Number 1, we're looking for where 3x to the third power minus x minus 5 equals 0. Now, over here in DESMOS, we're going to go ahead and type in, first of all, if you haven't ever used DESMOS before, you're going to want to open up a new tab. You're going to want to type DESMOS in, DESMOS, and you'll be able to access the graphing calculator right away on the main page. We're going to go ahead and type right here, we're going to type 3x to the third. For the to the third power, you're going to need the caret key, so shift 6, we'll bring that up there. Third power, you're going to push to the right on the arrow pad to move the cursor down to the main line, minus x minus 5. And right away, you'll see the graph right there. Now, one thing that's nice about DESMOS is you can just click and drag, and you can use your mouse wheel to zoom in or out. Really nice feature for a lot of things. Now, we want to know when this equals 0. We're looking for when does this graph equal 0? Where or what value of x will give us 0 as an output right there. So to do that, all we got to do is, well, here's the x-axis right there. So click on it, and it will just straight up tell you what the answer is, 1.278. Now, on my calculator, I rounded up to 1.279. We'll see. Maybe DESMOS rounds differently than I do. Maybe the math is slightly different there, but there you go. It's because I'm just barely not on that point. There we go. 1.279. See, I knew I was right. DESMOS does actually. You can zoom in. Look at that. You actually does make a point right there. You can click on that point and anchor it, and there you go. That's all you got to do. Let's try another one. Let's go ahead and close this off. We'll go back to our zoom out a little bit. For number 2, we want to know when 2x squared minus 1 is equal to 2x. We want to know when they're the same thing. So for this, we're going to graph 2x squared. Again, using shift 6 to get the caret key there. Minus 1. There is the parabola of that graph. Now we want to graph a second graph. You can either just push enter on your keyboard, or you can click this little plus sign there to get another one. We'll do 2 to the x power. If you want to get fancy, you can give these things names like f of x. DESMOS is wonderfully fluid when it comes to doing whatever you need it to do. It's there for you. Now, what you might notice right away is that DESMOS actually gives you the 2 points. They're right there. It's got little gray points. If you click on them, they turn black, and it will just kind of anchor them and leave the answers right there for you. So there they are. There's nothing more to do. No crazy. You don't need to learn any sort of weird key commands on this thing. You just kind of click on them. It shows you the answer. So there it is. I think I wrote down that negative 8.79 and 1.323 were the 2 solutions. So there they are. Ha! DESMOS is a very effective tool for this kind of problem. Number 3, again, has a pretty bonkers problem that we got to answer. 2 natural log of x minus 1, x plus 1, and then 5 cosine of x. Now, this one can be a little tricky. Let's go ahead and we'll do the same thing. 2 natural log of x plus 1. You can just type ln, and DESMOS knows that's natural log. Good tool. Down below, we're looking for 5. Again, just type cosine, C-O-S. Whoops. 2 cosine. It just knows cosine. It kicks. You'll notice that it does turn from italics to standard text. That means it recognizes, oh, that's a thing. Cosine of x, right there. And there's the second graph. Now, specifically, we're looking for where these two graphs meet. Oh, did I graph that? Oh, 5 cosine x. I was like, there's 2 solutions on this. Now, you actually notice that DESMOS actually identifies several solutions. There's at least 3 that I can see on this graph right away, but we only care about the ones that go from 0 to 2 pi. Now, you can change the window. If you go, let me move this window a little bit. Let's just keep DESMOS in the kind of the bottom quadrant right there. If you click this little wrench tool right there, you can go in here and you can actually change the window. And we really only care about the window from, let's see, I wish I could, can I select all of that? Perfect. We want to change that to 0, and we want to change this to 2 pi, which you, again, I don't know if you can barely see it on there, but if I type pi with the keyboard, it actually changes it to pi right away. And there you go. It changes the window from 0 to 2 pi, which is the 2 answers we're looking for. 1.242 and 5.564, which are the 2 answers that I identified in the other video. 1.242 and 5.565. It's worth mentioning in this video and also in the last that if you're given a question on the calculator portion of the AP test, you do not need to show any work. All they want is the answer. That's why it's on the calculator portion. They understand that this is a question that anybody, engineering, college students, whatever, anybody would just ask a calculator and tell the answer. What they care about is that you know what to tell your calculator to do. That's the key. Let's talk about the next question, number 4. Now this one, let's get a little fancy for this one. We got a system of equations given to us, and it's in kind of a function notation. So we get to practice that too. Make it just big enough to fit in that top corner there. Okay, so first of all, I'm going to zoom out. Nice thing, one thing I love about DESMOS, you can just change the window by just clicking and dragging, whatever you want to be. Of course, might want to take this out to like, I don't know. This works. This is fine for me. All right, let's get our functions out of there. Let's go ahead and type f of x. Let's name it f of x equals x to the 4th power minus 6.5 x squared plus 6x. Oops, I pointed a subscript there. 6x plus 2. There's the first one. Oh, it's got a little error there. I accidentally added a subscript. And then g of x. Now, you don't have to give your functions names like this in DESMOS, but you know what? You might as well practice it. It is a helpful tool to be able to do. Again, one nice thing, DESMOS just knows that e is that constant, 2.718. So you just type e, it's good to go. We're going to put some stuff up in the exponent, though. It's x squared minus 2x. A lot of stuff there, but this is the challenge of most calculator-based questions on your AP test, is putting them in the calculator. When you see a function like these, you're like, oh, this is a calculator question. I'm not doing that by hand. Nobody would. Now, again, it looks like there's 3 answers here. I just want to point out that DESMOS does, in fact, point out 4 key points for us. There is that right there. There's the 3 intersections. But I also noticed little gray dots right here and here. And we'll talk about that in a minute. Those are your maximums and minimums. So DESMOS knows already automatically where all the key points are. It knows what you're going to ask it, and it will just tell you what they are if you click on them. Again, we really only care about the x values here. One thing we'll talk about in the next question, we don't really care about what the y value is. We just care about where it happens. So the answers here are x equals 0, x equals 1.033, and x equals 2, which are the 3 answers I believe I had written down in over here. Oh, see, look, there they are. 0, 1.033, and 2. Again, there's the 3 answers that we're looking for right there on your screen. Only care about the x values. We don't care about the y's. For question number 5, this is a minimum and maximum question. If you're looking at the directions, they want you to use the calculator to find the relative maximum and relative minimum point of the given function. Let's go ahead and make that function happen. Only one function here, so we don't need to type h of x, but I'm going to do it anyway because why not? This is already going to be a short video. We have 2x to the 5th power minus 3x to the 4th power plus x minus 4. And there you go. Now, this does require a little bit of knowledge for you to know what a relative maximum is and what a relative minimum is. The idea here is if you zoom way out on this graph, you'll notice that it's tough to see actually, but so there is no absolute minimum or absolute maximum. This graph goes on forever to negative infinity and forever to positive infinity, kind of like this. But there are a couple points where are kind of the top of the hill and the bottom of the hill, so to speak, and those would be right about here, somewhere in there. I see by clicking on the graph, Desmos automatically notes it for me. So again, if you click on the actual graph, you'll see that 3 gray dots emerge on the graph. One of these right here, that is the y-intercept. It's important, but we don't care about it in this question. The relative maximum happens right here. Now, this is actually a case where we do actually care about the whole point. I didn't mention this in the other video, but the relative maximum is at 0.531, negative 3.623. The x-coordinate is where it happens, and the y-coordinate is what it is. Those are not the same thing, and oftentimes they're asked for in story problems, but here all you need are the 2 coordinates. So 0.531 and negative 3.623 for the maximum. Make sure you clearly label it, as I have done in my answer. And for the minimum, again, if you click on that point, it just tells you 1.131, negative 4.077. That's it. So Desmos, you know, it's a better tool. Oh, that's Facebook. Get out of here. Desmos is a better tool when it comes to like finding key points, because it just, like I said, you click on the graph and it just knows where the points are. Y-intercept, maximum, minimum, x-intercept. Like, you don't need to do any of these weird, funky key commands, but you just can't bring Desmos into the test with you. So it's useful to know how to do those things on this little pocket device too. It's up to you which one you want to use. As long as you understand the concepts, that's the key. Hey, I'm glad you watched this video. I'm glad you made it to the end of the series. The summer packet keeps you fresh, keeps you on your toes, keeps you thinking about things you got to think about throughout the summer. So hopefully these videos are of help to you. I can't wait to work with you in the fall. It's going to be a great class. It's going to be a great year. Already excited about it. So I'll see you in the next video, which might be in September. Until then, enjoy your summer, my friends. I'll see you then.